Okay, so how is everyone today? Good. All right. So today's the, what, 24th? Good. 2-4. Last time we were talking about exponent rules, and we just basically wrapped that up. Good. So now we're in section 1.3, and it's called something like radicals, which turns out is probably less exciting than it sounds. So the first thing that we're doing we'll define is square root. So square root. All right. So I'll say let x and y be in the reals. So those are just any old numbers. And then TFAE. So we'll use this initialism a lot in the course. So since this is the first time, I've got to say what it is that I mean by that. TFAE stands for the following are equivalent. All right, so what that means is that I'm going to make several statements, and all of these statements are going to mean logically the same thing. It's just two different ways to say the same thing. So first, y squared is equal to x, and y is greater than or equal to 0. So those two together. That statement is equivalent to this statement. So one of the tasks that we want to do and learn in college algebra is solve equations. So here's an equation because we've got an equal, and then on either side of it we've got a thing there. So what we want to do is we want to get this equation, and we want to solve for y, which means that we want the left-hand side to have just a single y, and it's not being combined with anything else. Okay, so y squared, remember, means y multiplied by y. So that means that at the present time the left-hand side has like two y's, and they're multiplied together. Okay, but we want there to be just a single y. So we want to be able to say y equal, and then now this x is still going to be on its right-hand side, and in some sense, I'm not finished, but what I'm saying is that in some sense, what has to occur is that 2 has to go to the other side. We've got to get the 2 to change sides. So when the 2 changes side from the left-hand side of the equation to the right-hand side, it changes its shape and entire appearance, and looks startlingly different. It looks like this. Okay, so what I mean is that if these two conditions are true, if y squared is x, and moreover y is greater than or equal to 0, then this statement is true. So this fancy house-looking thing, in case this is the first time you've ever seen it, that's called square root. So this is you pronounce this out loud. Y is square root of x. Yes?
In this instance, could you also say y is equal to x over y?
Yes, but then you wouldn't have solved for y, because there'd be y's on the left side and the right. Yes?
And so since it's y is greater than or equal to 0, it wouldn't be plus or minus square root of x.
Right. So then, here's the deal: is that it's quite likely that you've probably heard of square root before, and I've got some bad news, and that is that the first time that you learned this you know, from Mrs. Doolittle in 7th grade or whatever, it's likely that it was not explained to you correctly. And so here, the thing that's usually left off in grade school and not talked about is this thing right here. And as a result, it causes great difficulty for students in college algebra. So now we're going to address these difficulties. Okay, so in particular, I could ask, what's the square root of 9? 3. Now, a common answer that students give, especially, you know, maybe if you're like reluctant to, you know, to call something out, you might say something like plus or minus 3. And that's not right. That's incorrect. It's not correct, but let's be clear. What do you get if you, the question, what is the square root of 9? That's asking, would you please give me something such that when you square it, you get 9? But it's also asking something else. So what do you get if you square 3? 9. Okay, no dispute. What do you get if you square negative 3? 9. Again, there's no dispute. Nevertheless, the square root of 9 is 3. It's not negative. It's not negative 3. It's not positive or negative 3. It's positive 3. There is no other. Now, the reason why there is no other, in the end, is because of this. There is no other. Because understand what this is saying. Is that if the square root of 9, if we say that that's equal to y, so this and not something like plus or minus 3, not anything like that. The reason why this is the case is because, consider, what if we took this equation and then we kept the 9 on its side and we kept the y on its side, and what we wanted was the square root to change sides. Okay, so you want this square root to go to the other side, right? You want this to travel over there. So when it travels to the right side, what does it become? It becomes a square, right? But now you need to look at these two. See, the thing is that when the square root goes from that side to that side, you also pick up something else. You pick up what? This. So this is the part where you know, college algebra students usually go off the rails. So 9 is y squared, and y is greater than or equal to 0. So now what y's will satisfy this? So notice that as for this one alone, if I cover that up, 3 and negative 3 satisfy this. You can plug in 3, you can plug in negative 3. But when you have this, only 3 will work. As a result, you know, I could ask something like, you know, like what's the square root of, I don't know, 16? 4, right? Good. But now there's another matter that's unstated up here. It's unstated because it's implied. Now these two things are matters of definition. But there are consequences that now we need to delve into. So specifically concerning these, what I'd like for you to observe is that, well, because we're squaring y, let's consider y, you know, we're squaring it. So what if y were positive and then we square it? Then what kind of thing would we have? Would y squared be negative 0 or positive? It would be positive, right? If y is positive, you square it, the result's positive. What if y is 0 and you square it? The result is 0. What if y is negative and you square it? The result is positive. Do you observe that even without regard to this condition, for any y whatsoever, y squared is going to be greater than or equal to 0? It must be the case. And because x is y squared, that means what about x? That means that, well, it means that x is non-negative. And again, you know, this is a consequence. And again, I'll say that, you know, mathematicians are to some extent like the lawyers of the science world, you know, kind of in a funny way. Because, you know, she said positive and I said, well, non-negative. And unless you're paying close attention, you might think, is there a difference? So what's the difference? Can be 0, right? Okay. As a result, what that's saying is that because x is the thing that's being put inside of the square root, because x is the input to the square root, and because x is greater than or equal to 0, that means it's not permissible by the definitions to calculate the square root of a negative number. So if I were to ask something like this, say, the square root of negative 25, the correct response is to say that this is undefined. Any questions so far? Okay. So now, last time, the very end of last time, we ended with something like this. If you take x multiplied by y, and then you raise this to exponent n for some natural n. We went through it. We used that same thing where you say, oh, okay, that means repeat, all with product. And then we had x, y, x, y, x, y, x, y, x, y, and then we commuted them all into the order that we wanted. You know, you remember? So what's the formula for this one? Very good. Okay, that's last time. And now today we're doing something that's in fact quite similar. Specifically, what we're doing is we're saying, okay, suppose that we still have this xy like that. Still have it like that, but instead of putting it in a group and then giving it an exponent, we're going to put it in a square root, like so. So can you see how these are like similar? So just like this exponent, and you know, pay close attention because this is a multiply, okay, not an add. Okay, multiply, and that's a multiply. So this exponent, in a sense, you know, you give it to the x and you give it to the y. Similarly, the radical will work in the same way. That you'll get this. Square root of x multiplied by square root of y. But, you know, as you can see from the definition, you know, there's a little bit of, you know, tricky business regarding the signs of x and y, where square root is concerned. And as a result, there's a little bit of extra we have to add here to make sure that this will work. This is possible when x is greater than or equal to 0 and y is greater than or equal to 0. They must both be independently non-negative, yes?
Would it not be root n since it's not necessarily 2? Because you're doing square root, which would mean it would be 2, right? So if n was 3, wouldn't you do root 3, right?
Oh, okay, well, I'm just reminding you that we did this last time.
Okay.
And at the present point in the exposition, I don't even know what root 3 means, in a sense, I guess. So the reason for this red here, the reason for the red, is that this is okay. It's fine for you to calculate the square root of, say, like negative 4 multiplied by negative 4, because that product is inside of the radical. When you do it, negative 4 times negative 4 is what? Is 16. And can you compute the square root of 16? Yeah, sure you can. But you cannot do this. You cannot say that this is equal to the square root of 4 multiplied by the square root of negative 4 multiplied by the square root of negative 4. You can't split it like that. So can you see that what these two say is that well, you can only perform that split if both of these are non-negative. Okay, so this is not true. Good. So let's see how this gets worked out in an example. Any question about the definition? Okay. So the way this gets worked out in an example is something like this. Is, on the previous page I asked, what's the square root of 9? And everybody said 3. And, maybe there was weekly someone saying negative 3. And then we said, no, not negative 3. But here's one that's slightly more complicated. Square root of 54. Now 54 is not a perfect square in the same kind of way that 9 is. It doesn't have an integer square root. But what we want to do is we want to, in a sense, simplify this square root. So how does 54 factor? 6. What is it? 6 times 9? Yeah. So then I'll do it sort of, little bits. So 2 comes out. I can do that. So then 27. 2 times 27. And then how does 27 factor? Okay. So then you could write it like this. 2 multiplied by 3 multiplied by 9. Ah, now that's nice. That's nice. That's nice because, well, according to the previous page, we can, because this is the product of 2 and 3 and 9, we can give, in a sense, the square root to each factor. We can square root the 2, square root the 3, square root the 9. And the thing is that concerning 9, you can do the square root of 9. What is it? 3. It's 3. So as a result, what I'm saying is that the thing on the previous page says that you could write it like this. The square root of 2 multiplied by 3, and then multiplied by the square root of 9, like that. I'm leaving the 2 and the 3 together in the end because you're not going to be able to get a perfect square out of that. So you could write it like this. Okay? And, if it is the case that you've seen square roots before, you're probably just a little bit disturbed by me writing the 3 on the right side. That's probably disturbing to you for reasons you can't really fathom. You just find it uncomfortable. Well, in the end, I don't know the reason you are either, other than your teacher probably always put it on the left side. Is it permissible for me to put it on the right? Yeah. What's the name of the permission? C word. The commutative property, right? So you're asking, in a sense, you kind of maybe want to put the 3 in the front, which is to say you want it to say 3 times square root blah blah. To put those in the other order, yeah, you can do that. You can commute them. But I would encourage you to understand that just because you always saw it that way doesn't mean it always has to be that way. Good. Any questions so far? Yeah.
For it to be considered fully simplified, do you have to multiply the 2 by 3 so it's square root of 6, or would you just keep it in the 2?
Either way.
Okay.
So long as all of the integer square roots are out, right? It wouldn't be okay to leave a 16 in there, but yeah, you could leave I don't know, a 15 in there. That'd be fine because that's 3 and 5. Okay, other questions? All right. So now we need a remark about absolute value. Okay. So this thing that I just wrote here is pronounced out loud as an absolute value of x. So that's an x, and then it's in between 2 vertical bars. its definition is the following. So I'm going to write something, but at any rate, what I've started out is I wrote this big left brace. And the reason is that that's the convention to say that what exactly we're going to do with that x sort of depends on what that x is. Now, before I actually write down the definition of the absolute value of x, I've got a question for you. Well, first I want to describe what the absolute value of x does. So all numbers, all reals, one way to break them into groups is you could say, well, you've got all the numbers that are more than 0. You've got all the numbers that are 0. And then you've got all the numbers that are less than 0. So those the names of those groups are respectively positive, 0, and negative numbers. All right. So what the absolute value does is you give it a number, and you could think of it like it sort of inspects it. And if that number happens to be negative, then it flips it to the positive version. Otherwise, it does nothing. So like, the absolute value of 8 is going to be what? Just 8, right? Because, you take a look at 8 and say, that's positive. Yeah, you can go on. But the absolute value of negative 5 is going to be what? It's going to be 5. Okay, because you inspect the negative 5 and you say, oh, that's negative. But it's a negative 5, so I'm going to make it a 5. All right. So now I've got a different question. Let's consider the expression negative x. Okay. Is it conceivable that that negative x could be positive? I mean, is it? What kind of x could result in negative x being positive? But can you give me a specific number, maybe? Negative 4, right? Because if x is negative 4, then negative x is negative 4, right? 4. Right? Okay. So what the absolute value of x does is it says, well, okay, if you give me an x that happens to be greater than or equal to 0, then the output is just whatever you put in. Like the absolute value of 8 is 8. What's the absolute value of 0? 0. So the last possibility is when x happens to be negative. And so what's the formula I'm supposed to put here? When x is negative, what's the positive version of x? Negative x. Now let me say it again because I got a strong look. I got a strong look of like double speak from y'all. When x is negative, how do you write the positive version of x? Negative x, right? Just like the positive version of negative 4 is negative 4. Got it? Good. Okay, so then these individual lines are referred to as clauses, and they're numbered top to bottom, starting with 1. So out loud you might say that absolute value has 2 clauses, and there they are. So to make sure that we understand how this mechanism works, I could ask, okay, what's the absolute value of say 13? It's 13. But in order to be able to do that, I'd like for you to please identify which clause are we using? The first clause. Why are we using the first clause? Right. Because in the definition, x is the name that we're using for the input. And here, on this specific request, the input is 13. And the question is of these choices, which is true? Is 13 greater or equal to 0? Yeah. So then we're using the first clause to make this determination. And the answer is 13. All right. What's the absolute value of negative 14? 14, right? 14. Now, fine, but you need to tell me which clause we need to use and why. Second clause. Why are we using the second clause? Okay, good. because x is the name of the input. Here the input is negative 14. The second clause is the one that tells you what to do with the negative input. And so what that clause is saying, it's saying that it should be negative 14. Right? Now I'm not I don't need you to write that on such a simple example. I just want to make sure you see how it's working. It's saying negative 14, which of course you would finally write as 14. Okay. What about the absolute value of 3 minus pi? Now, I don't want any decimals. It won't be 3 plus pi. It won't be 3 multiplied by pi. Let's think about it for a second here. You know, I don't want a decimal approximation. Nevertheless, you need to know about how big pi is. So about how big is pi? 3.14. I'm talking about the circle constant, pi. So about 3.14. Okay. So that means that we've got a 3 there. And we're subtracting something that's a little more than 3. And in order to come to the answer, what we really need to identify concerning absolute value is which clause are we using? We're definitely using just one of the clauses. Which one? The second one. Okay. If the second one, then why the second one? Okay. Yeah, in the end, the question boils down to 3 minus pi. Is it negative or is it not? It's negative because pi is a bit more than 3. So 3 minus a bit more than 3 is negative. Okay. So this is negative because pi, you know, starts out with 3.14 ... And therefore 3 minus pi must be negative. So that means that we're using clause number 2. And so what are we supposed to do? So, you know, I'm obscuring what it is that what's in the absolute value now. But I'm going to remember that we've established that it's negative. So whatever it is I'm covering up, if it's a W, I need to write negative W. If it's a giraffe, negative giraffe, right? Whatever it is, it's negative, so we need to write negative that thing. So the answer is this, negative 3 minus pi. That's the answer. I don't want a decimal approximation. I'm not interested in that. Now, a simpler way to write this, okay, would be to know that, you know, among the things that is expected knowledge before you got here is besides things like the associative property and the commutative property, there's also a D word, the distributive one, okay, which is to say that this negative can distribute into here, and you get what? Very good. Negative 3 plus pi. But now I'm gonna do this one more time to just remind you of something, or maybe tell you for the first time. I don't really know. Is that using the exact same considerations, you could say, oh yeah, 3 minus pi, that's negative. And when you want to get to when you negate a subtraction like that, what you actually do is you reverse the order of the terms. What I mean to say is that negative a minus b, something that looks like that, when you do it, you could do it just like that. There's nothing wrong with that. But you can write this as just b minus a. Okay, so then negating a subtraction is the same as reversing the order of the subtraction. So in that way, you can write, you know, just pi minus 3, like that. That's a slightly shorter way to write it. I just want to remind you that this is a thing. You know, and also, you know, if you were to poll a bunch of, you know, folks, people, and ask them, you know, which one would you rather write? Usually it's this one. The reason is quite simple. You just count up the number of pen strokes, and this one has 2 less because you don't have to write a plus. Yeah, that's a lovely thing about humans. Because I love human beings. I think that we're the most interesting things in the universe. But we all have this nice property of economy, which is like a polite way to say lazy. And I really don't mean that negatively in any way. I really think that that's one of the best things about us. So I'm just trying to play into your biases. Here's a shorter way to write something. Good. How about the absolute value of x squared plus 5? And this is just for any real number x. What do you think? Well, I mean, there's no square root here. I'm not asking you to do any square root business. None of that. Just x squared plus 5? Okay, why?
Because if you square something, it can't be negative. And if you're adding 5 to it, or like, not negative, it's non-negative?
Non-negative.
So wait, I'm trying to use like mathematical terms.
Yeah.
But like you're adding 5 to it anyway, so it's still be positive.
Okay, I agree entirely. So let's consider. X, what I mean by this is like x can be any real number. Suppose x is positive. You're going to square it, and then what about the result? Positive, and then even after that, we add 5, and that's positive. So that's the case if x happens to be negative. What if x is 0? Then you square it, and you get what?
0.
And after that, you add 5, and that's 5. That's a positive thing. And then what if x happens to be negative, and you square it? A positive thing, and then you add 5? It's positive, right? So do you observe that x squared plus 5 is in fact always greater than or equal to 5? It can't get any smaller than 5. So which clause do we use? First clause. In the end, again, like we said, because x squared is greater than or equal to 0, it can't ever be negative, so it can never pull on that 5 to become a negative sum there. All right. Any question about this? Now, one thing I want to just remark about penmanship and writing stuff down in a math class, and that is that in case you haven't noticed, I've got a lot of quirks, and like when I'm writing English, like non-math stuff, I write it in block print, and then when I'm writing mathy things, I write it in kind of like a script style. Okay, and that's so you can tell the difference. But among the various differences, you might notice that I write a 1 like that. It's got a little hook on it. Does anyone know the name of that hook? You probably actually do if you've done anything with the word processor. Yeah, it's a serif. Okay, but now for that was for 2 non-existent points. What about for 8 non-existent points? What does serif mean? You're right. You hear it in fonts, but serif is a word eventually going back to Sanskrit that means something. It means, yeah? No, it means foot. Foot. So like when you're writing those, like on your word processor, and you've got the letters and the numbers that got the little things that they sit on, like the 1. It's got little feet. Yeah, those are called serifs. And I think it's kind of funny that hook up there that's more like a hat is called a foot. But at any rate, the reason why I'm mentioning this is because you'll find that a lot of your math instructors write 1s like that, and there's a reason. So the way that I'm writing them is like this. And the reason why I write them is because would you please tell me what this means? Does anyone care to guess? It's actually the absolute value of -1. You couldn't have won, because whichever one you said, I would have said the other one. Right? Okay, so then do you see that there's a problem here? Is this the absolute value of -1? Is it 1 minus 11? Who knows? Right? Whereas this cannot be mistaken. The 1 has a hook, a serif. Now, I mentioned that to you because to some extent and to some degree, you're just trying to like optimize your grade, in the class. And what you want to avoid is like when the grader's grading your quiz or homework or whatever, and they've been grading for like 4 hours and they haven't had, the coffee ran out in the first hour, okay? And they can't read anyone's handwriting, and then they see your paper and you've written something that could be 1 minus 11 or the absolute value of -1. You don't want them to make an uncharitable assessment of what you've written there. Good. Nevertheless, the graders are professionals. Fine. So here's another unfortunate point where I need to sort of say that your grade school teacher might have misled you about some things. So I'm going to write it real big. The square root of x squared. What is it? No. No. It's definitely not x. Plus or minus x is even worse, because I'm not trying to be mean. I'm really not. But it's even worse because the square root is only permitted to have one output. And if you say plus or minus x, you're saying that it can have two outputs. Okay, so it's not x. Nevertheless, I'm going to write x for a moment, and I'm going to come back and I'm going to fix it. So right now, this is wrong. Nevertheless, this is the most common wrong answer that students give in college algebra. But now I'm going to make it right. So specifically, what I want you to observe is there's two actions occurring. There's a square root, that's something that occurs, and there's a squaring, that also occurs. Now, which one occurs first? The squaring occurs first. And then after the squaring has occurred, then square root occurs. So now, the punctuation for raising to an exponent, remember, is a caret, like on your calculator there. So if you take a 3 and then you square it, the caret 2 means square it. What do you get when you do that? You get a 9. And then suppose that after you do that, you give it into the you give it as the input to the square root. What do you get? You get 3. So this line right here would lend credence to this one, to this being correct. So what this is saying is that well, if you do that, if you square it and then you square root, you should just get the x back. So this would sort of be evidence that maybe this should be right. Because you started with this and you ended with that. But now I'd like you to consider, what if you start with a -4 and square it? What do you get? You get 16. And then after that, you give that to the square root, and what do you get? 4. So you started with -4. The input was -4, and what came out? +4. So this needs to be edited. How do we fix it? What do we have to do to fix it? We need some kind of thing so that when you put in a 3, out comes a 3, and when you there you go, that one. She said it. Absolute value, right?
Yeah. Absolute
value. It's this one. These red bars right here. These are like the story of Don Quixote? It's an interesting story. It's really long, though. But at any rate, at some point in the story, you can't really tell if it's like fantasy or if it's real, because it's sort of like the whole story is like surreal. But at one point, he's literally like fighting windmills. Yeah, because he thinks they're dragons. These two red bars, these are the windmills that I fight in college algebra. So believe it or not, you know, some of y'all that are in here today are going to lose points next week because of those red bars right there. I don't claim to have any like power to tell the future, just statistics. So please think of it, consider it carefully. So let's have an example of doing this. So if we have something like the square root of now I want to put some number in there, 24, and then I'm going to say multiplied by x cubed and multiplied by y to 5. And what I am requesting of you is that I want you to get out as many factors as possible. All right. So now, because they're all multiplied together, in a sense, we can sort of do them like piece by piece. So 24. Think of the various ways that 24 can factor. Are there any ways it can factor such that one of them is a square? 6 and 4. So a first thing to consider is to say that, well, you could do it like this. 6 and 4, as you say. So now that 4 can come out because it's a square. And when the 4 comes out, what does it come out as? 2. It comes out as a 2. So you could write it like this. 2 multiplied by square root, and then what goes in the what stays in the square root? Okay, very good. All right, good. So now I want to deal with the x's. Now here's the thing, is that remember that x cubed really is a shorthand notation for what? X, right? All multiplied. So what we're allowed to do is we're allowed to smuggle pairs out of the radical. So x cubed is xxx. So I'm going to rewrite that x cubed in this sort of curious way. I'm going to say that in fact x cubed can be written as x multiplied by x squared, because there's one of the x's and there's the other two. And then concerning the y's, I could write that as y multiplied by y squared multiplied by y squared. And the reason to do that in the end is I just want to make as many pairs as possible. So now I'll deal with just the x's. So here I see a pair of x's, and that can come out of the radical. Now the x squared comes out as what? As absolute value of x. So 2 multiplied by absolute value of x multiplied by square root of 6 x, so that x, that one had to stay inside, and then multiplied by y squared. Okay, what else can come out? Right, in fact 2 pairs of y's can come out, right? So each of these can come out, and each comes out as what? As absolute value of y. So this pair comes out as absolute value of y. That pair comes out as absolute value of y. So what remains in the radical? Okay. Finally, because we've got just that much right there, we've got absolute value of y repeated twice with a multiplication. That means we can write that slightly simpler as what? Absolute value of y squared But now here's the deal: is that concerning that absolute value of y squared, you know, if y were 5, say, if that were the case, then that would mean we'd compute the absolute value of 5 and then square it and get 25. Now, if it were negative 5, we compute the absolute value of negative 5 to get 5 and then square it to get 25. But what if we just, for that y, for that right there, if we just said, forget the absolute value? Would that be okay? It would be okay.
Would?
Yeah, it would be because we're squaring it. Right. Because we're squaring this one, that means that for the y's, actually, we can get rid of the absolute value. Not the x's. Why not the x's?
You're not squaring it.
Not being squared. Now, if that didn't say, if that it says y squared, what if it said y cubed? Could we get rid of the? We couldn't get rid of it. What if it said y to 4?
Yeah.
Then it would work. So, that being the case, coming right to the end of the thing here. The first thing that we're going to talk about next time is that this thing that we've just been talking about is called square root. So next time, we're going to deal with this. I just need your attention for 20 more seconds. So square root is when n is 2. When n is 3, it's going to be called cube root. When n is 4, fourth root, etc. And there's going to be a big difference between the behavior of when n is even, like the square root, and when n is odd, like the cube root. Have a nice weekend.